I recently watched a YouTube video that made the rather unfriendly claim that principles like the solid principles are just made up, they're fiction, they have nothing to do with software, and that they are the source of bad code. Okay, all right, so let's go through this because I think it's probably worth just, talking about it a little bit. Do we believe that software systems should be decomposed into modules? I mean, this is an old idea, right? Excuse me while I turn on the light. This is an old idea. It goes way back into the 1960s. Is it a good idea that we break things up into modules, or should we just have, our software systems contained in one gigantic source file, all monolithically distributed? I think we can all agree that modular programming is probably a reasonable design principle. Well, if that's the case, then would it be a good idea to have a system decomposed in a way that various users are focused onto particular modules? So let me explain that. Let's say we've got a system and it's got two different kinds of users. There's the normal users and there's the system administrators. Now, would it be wise from a design point of view to make sure that when the users request changes, that those changes do not cause changes in the modules that the system administrators depend upon? Right? We don't want the system administrators' features intermixed with the users' features, right? I mean, that's good, isn't it? And by the same token, when the system administrators ask for changes, wouldn't it be a good idea if the modules that contain the user's features aren't affected? I mean, wouldn't you think that would be a reasonable kind of design principle? That is the single responsibility principle. That's what it's all about. And by the way, you could measure that, right? I mean, you could track the changes through the system and see what modules they land on and whether or not changes from one kind of user affect modules that have other kinds of users' features in them. Okay, so that's the single responsibility principle. Now, another. Is it a good idea that when you have a change in low-level detail, that high-level policy modules should be unaffected? I mean, do you want to separate the high-level policy modules from the low-level detail modules such that when a change to a low-level detail happens, the high-level policy remains unchanged? Would that be a good idea? That is the open-close principle. And by the way, you could measure that. You could track the changes through the system, those that were at low-level details, and see if they touch any of the high-level policy modules. You could measure that. Let's do another. The Liskov substitution principle. Oh my, I know, big highfalutin name. Okay, what does that really mean? Well, I think we all agree that when we're writing programs, we use types. Our data structures tend to be organized into types of some kind. They may be statically compiled, they may be dynamically compiled, but it doesn't matter. They're types. And of course, some types are subsidiary to other types. They are subtypes. Now, I'm not talking about object orientation here. That has a special role in object orientation, but this doesn't need to be an object-oriented language, right? We can have types and we can have subsidiary types. Isn't it a good idea that a module that uses a type can use a subtype without knowing that it's using a subtype? Wouldn't that be a good idea? Would it be a bad idea for the module that thinks it's using a type to be forced to know that it is being given a subtype? That's the Liskov substitution principle, right? And by the way, you could measure that. Just, look at the changes, see how they affect things, count the number of if statements that check whether or not the incoming type is actually one of the subtypes. That's the Liskov substitution principle. So probably a reasonable principle, and I would imagine measurable, and certainly not, made up and fictional. Okay, all right. Is it a good principle that you should write modules that do not depend on things they don't need? You've got module A and it depends on module B, but module B is loaded with all kinds of stuff that module A doesn't need. Wouldn't it be a good idea to avoid that situation? That is the interface segregation principle. And by the way, you could measure that. You could measure the number of elements in a module that are not used by the using module. So, okay, it's a measurable principle. You can use it, and it's probably beneficial. That leaves one last principle, which is, of course, the dependency inversion principle. Is it a good design idea that low-level policy depend on high-level policy? Or should high-level policy depend on low-level policy? Well, I'll let you answer that question. I think it's kind of obvious by now, but that is the dependency inversion principle. All of these principles are pretty easy to grasp at this kind of level. They get a little more complicated when you're dealing with languages like C++ or Java or Clojure or Elixir or whatever. But they all apply. They are not strictly object-oriented principles, although they have been called that. I've called them that myself. But they are not specifically object-oriented. And by the way, they are not fictional, made up, and they are not the source of bad code. So with that, have a good day.